Hello pre-calculus. Today we are going to be introducing the sine curve by unwrapping the unit circle. So we became acquainted with the unit circle during the last unit, and this compares three sets of data. As we move around the circle from the x-axis over here counterclockwise, we're keeping track of three things: the angle in degrees, the angle in radians, and the coordinates of points along the outside. So what we're going to do is only take a look at two of these pieces of information. We're going to look at how the angle in radians of your position around the circle relates to the y coordinate of the given point. And really what that is we are looking at our height above the x-axis or below the x-axis. So what happens when we compare our position in radians to the height above or below the x-axis? Well, we're going to find out just by pairing up the radians and the y coordinate. We're going to make our own xy point out of these two numbers and put it on the graph. So our first one is at 0 radians and 0 on the y-axis. So our first point is naturally going to be 0, 0. Our next point is at our first special angle, pi over 6. That's 30 degrees, but pi over 6 radians. And this has a y coordinate of 1/2. That means that we are 1/2 units above the x-axis as it sits right now. So what I can do here is just draw a line straight across to this plot, and it should hit that point right there, which we're going to call 1/2 on our y-axis, and we're going to keep going until we hit pi over 6 on the x-axis, and we're going to put a point right there. Actually, let me make my point in black right there. Okay, so we've got 2 points on the graph, and we're going to move to the next one. So our next angle is pi over 4, and that has a height above the x-axis of root 2 over 2. And that's just coming from the y coordinate of the point. So we can take our height and just drag it horizontally over until we are aligned with the x value of pi over 4. And we can put a point on the graph right here. Now what you should start to see forming is this curve as we approach pi over 2, because what we're doing is we are climbing and climbing to the top of the unit circle, where we will finally hit a height of 1. But it's not a straight line, it's more of a gentle curve. And you'll see that in our next step at the angle pi over 3. So at pi over 3, our height above the x-axis is root 3 over 2. I don't know what number that is specifically, but I know that on the graph it's going to show up right around here. And I'll put my point there because that is at the x value of pi over 3 and the y value of root 3 over 2. Which brings me up to the top of the circle at the angle of pi over 2. And our y coordinate is 1, because remember, the radius of this circle is 1. That's how we define the unit circle. So when we're at the top, we are at a height of 1 units above the axis. So we'll take this over to pi over 2. So this point right now is pi over 2 comma 1. Okay, we've made it a quarter of the way around the circle, which means that we should be able to complete the rest of it with a fair amount of speed. So I'll be speeding up a little bit through here, but it's the same principle. We find the angle that we're at. This next one is going to be 2 pi over 3, and we find the y coordinate. So we have root 3 over 2 once again, and you'll see as I draw this line across, we're actually going to end up on top of the other line that we drew. We'll go right through that point, and we'll end up right around here. So that point gets us to 2 pi over 3, root 3 over 2. Next, we are at 3 pi over 4 and root 2 over 2, and I can draw that line straight across, and it does land right on top of our other blue line, and we'll stop at 3 pi over 4 and put a point right there. And next, 5 pi over 6 and 1/2. Remember, we talked about symmetries on the unit circle, and we also talked about angle families and triangle families on the unit circle. So we had our 30-degree family, our 45-degree family, our 60-degree family. Well, that's why I've color-coded it like this, because those similarities show up on this graph as well. Once we hit pi, we are now back at a height of 0. So we went up to 1 and then back down to 0. So that means that this point will be the point pi, comma, 0. Okay, let me go ahead and label our starting point too. That was 0, 0. We'll need those in a little bit. Halfway around, and we've got halfway to go. Our next angle is 7 pi over 6, and that comes in at a y value of negative 1/2. So we had positive heights in the first half. Now we're below the axis, so we will see some negative heights. So let's draw this all the way across until we hit, oh, come on, right there. Until we hit 7 pi over 6 on the x-axis. Right there. Now your line doesn't have to be straight, but where you end up should be more or less precise. Next, we've got the angle 5 pi over 4. Comes in at a height of negative root 2 over 2. I don't know exactly what that number is. It's something bigger than 1/2, but smaller than 1. And it puts us right around here. 5 pi over 4, negative root 2 over 2 would be the coordinates of that point. Next, for our green, we have 4 pi over 3, negative root 3 over 2. And we'll draw that across. We're getting a little sloppy, but that's fine. We'll end up where we want to, because where we want to end up is right here. Okay? And now we're at the bottom of the circle. Our angle is 3 pi over 2, also 270 degrees, but you'll get used to radians soon enough. And the y-coordinate is negative 1, because now we are a full radius below the x-axis. So we can take this line and draw it all the way over here until we hit 3 pi over 2, and we'll put a point right there. And that point has the coordinates 3 pi over 2, negative 1. 5 pi over 3, the point is actually down here at negative root 3 over 2, but we can just carry this green line on a little bit further, and we end up right there. So we will put a point on the graph right there. Next, 7 pi over 4 and negative root 2 over 2. So I'm just going to carry that line out until we hit 7 pi over 4, which is right here on the x-axis. So I'll put my point down like so. 2 more to go. 11 pi over 6 and negative 1/2. So we can just carry this line out until we hit 11 pi over 6, which is right there. And my point like so. And the very last point, oh, I don't need to change color for that. Now we're not at 0 anymore, we are at 2 pi radians, having gone all the way around the circle once, but our height returns us back to where we started, at 0. So this point over here has coordinates 2 pi, comma, 0. So nothing left to do now but connect the dots, and you can see that the wave is already kind of forming. So what we're going to do is draw the wave as shown. Just connect the dots. Try not to make this like a series of straight lines. Try to make it a smooth curve, because it's supposed to be curvy. Not necessarily exact, just a nice curve. And that is our sine equation, y equals sine of x. So before we move on, we're going to get a little bit of detail out of the way. We can fill in a basic table of values for these points. I've already pointed out the 5 most important ones to you, but let's go ahead and recap by walking through the first half of this curve. with our values. So we were looking at angles 0, pi over 6, pi over 4, pi over 3, and pi over 2, and then their analogs in the second quadrant, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. So what this does is it takes us up from 0 to 1/2 to root 2 over 2 to root 3 over 2 to 1. And then back down, root 3 over 2, root 2 over 2, 1 over 2, and 0. So what we can also do is talk about the domain and range of this curve. So our domain, if you'll recall, is the set of all x values. So our x values are shown here on the x-axis, and in truth, I've only shown you a tiny portion of this curve. What would happen if we kept going in this direction? What would happen if we kept going in this direction? Well, we already made one trip around the circle. If we make another trip around the circle, we would see the same thing again. And if we went backwards around the circle, well, we would continue to see a similar pattern, but going backwards. So really, what this graph looks like is not just one up and down wave, but it's a continuous pattern of waves up and down, repeating infinitely. So the more times you take a trip around the circle, the more times you see this repetition, which means that our domain is infinite. So it actually ranges from negative infinity to positive infinity, because you can put any x value in, you can find any x value that you want and put it into sine of x, and it'll work. Now what about range? Well, the range is the set of all y values. So we think about the y values of this graph. And here it's pretty clear that we have a maximum and a minimum somewhere. But what are those maxima and minima? Well, the highest that we can ever get, we're thinking about the height above the x-axis, and the biggest that ever gets is 1, right? If you stay on the edge of the circle, you can't go past the edge of the radius. So 1 is actually the biggest value that we get out of this function. Likewise, -1 is going to be the smallest that we get out of this function. So our range we can write as this interval from -1 to 1, including those endpoints. So the range only covers the values between -1 and +1. So here we are on another blank page, and it looks exactly like the one that we just did. But I'll ask a different question this time. This time, instead of looking at the relationship of the angle to the y coordinate, what we're going to do is look at the relationship of the angle to the x coordinate. So we're no longer considered with the height above the x-axis as we go up and down. What we're looking at now is our left and right positioning as it relates to the y-axis. So it's a similar question, but it will come about with a pretty different answer, and you'll find that out as we go along. So my first point is going to be at an angle of 0 radians, and our x-coordinate at this point on the outside of the unit circle is a 1. So my first point will be the point 0, 1, right here at the top. We're going to do the same color coding here. At pi over 6, our x-coordinate is root 3 over 2. Well, I don't really have a good reference for where that is. Let me look back at the sine curve. Okay, so we saw root 3 over 2 was right around here. So I'm going to put root 3 over 2 right around here, root 3 over 2. And my point will be at pi over 6, root 3 over 2. There it is. Let me put it in black just so it matches. Actually, you know what? No, we're going to stand out. We're going to be different. This one's going to have colorful points. There we go. Next, at pi over 4, our x-coordinate is root 2 over 2. And root 2 over 2, I believe, was somewhere like right here. So at pi over 4, we will put our point there. Then at pi over 3, our x-coordinate is 1/2. Oh, well, I know where 1/2 is. That's right here. So 1/2 shows up right there. And we're already a quarter of the way around. At the angle pi over 2, our x-coordinate is a 0. So we started at the top of the y-axis here, and now we've ended up on the x-axis at the point pi over 2, 0. Okay, so we will continue around the circle in a similar fashion. At the angle 2 pi over 3, our x-coordinate is negative 1/2, so we drop down to negative 1/2 right there. Then we've got 3 pi over 4 and negative root 2 over 2. So 3 pi over 4 and negative root 2 over 2. We'll say it's around here, and we'll say it's around here. Okay? Next with the red, 5 pi over 6 and negative root 3 over 2. So we'll put a similar spot here on the axis just for reference. Place our point here. And then at the angle of pi, our x-coordinate is negative 1. So if you think of this in terms of our left to right positioning on the circle, this kind of makes sense. Because at the beginning, we are the farthest right that we could ever go on the edge of the circle. And we've gone all the way around, and now we are at the farthest left that we could ever go on the edge of the circle. So it would make sense that our point here is pi negative 1. All right, we're halfway around, halfway to go. 7 pi over 6 and negative root 3 over 2. These values are negative because we are to the left of the y-axis. We're on the negative side of the x-axis. Next we have 5 pi over 4 and negative root 2 over 2. So I'll use the point that I put earlier to help me place that one. Then the same thing with 4 pi over 3 and negative 1/2. I'll use this point that I put here to help me place that one. Okay. Back up to the x-axis, we are now at the angle 3 pi over 2. Our x-coordinate is 0. So that puts us on the x-axis here, and I will label this point 3 pi over 2, 0. Okay, almost there. Back to green, 5 pi over 3 and 1/2. So 5 pi over 3 would be this spot here and this spot here. Then we've got 7 pi over 4 and root 2 over 2, which is going to go here. Again, I'm using the points that I placed earlier to help me place these. My last, well, second to last point will be at 11 pi over 6 and root 3 over 2. So that looks like it should go here. Now last, but certainly not least, we have our final position, which is not 0, but 2 pi, because we've taken a full trip around the circle, and we end up back at the y value of 1. So that point is 2 pi, 1. All right, so same as we did with the sine curve, we will connect the dots, and we start at the top and go down to the x-axis. And then we dip below the x-axis until we hit a y value of negative 1, and then we come back up. Remember, this is supposed to look like a curve. It's probably not going to be perfect, but, you know, that looks all right. Looks pretty curvy. So this shape looks very similar to sine, except for we don't have a full up and a full down. We kind of start up, and then we go all the way down and all the way back up. So this is actually the shape of the graph of y equals cosine of x. We talked a little bit before about how the x coordinates of these points represent the cosine values of those angles. And indeed, that shows up here on the graph of y equals cosine of x. So before we move on, we're going to take a look at this table of values. We're just going to do exactly the same thing that we did with sine and fill this in for the first half. So we had angles of 0, pi over 6, pi over 4, pi over 3, pi over 2, and then their analogs in the second quadrant, 2 pi over 3, 3 pi over 4, 5, whoops, come on, over 4, 5 pi over 6, and pi. But this time our values are slightly different because we started at 1, and then we moved to root 3 over 2, root 2 over 2, 1 half, and 0. Then we moved into negative values. Negative 1 half, negative root 2 over 2, negative root 3 over 2, and negative 1. And we can also talk a little bit about the domain and range. So domain, remember, is all of my x values. And same with sine, we can continue this pattern indefinitely on either side of that wave, because you can keep going around the circle as many times as you please. So that shape will eventually look almost identical to that of sine, meaning that we can go forever to the left, forever to the right. So our interval for the domain will be all of the numbers from negative infinity to positive infinity. And for the range, we can think of it very similarly as well, because this curve has a minimum of negative 1, and it has a maximum of positive 1. So all of my y values are going to be between negative 1 and positive 1, including those values. By the way, that's why I'm using brackets here and not parentheses. If I were to use parentheses, if I were to use parentheses here, negative 1 to 1, that would be the interval that doesn't include those endpoints. But we do include those endpoints because they are a part of our range. Anyway, let's get into some practice problems graphing transformations of sine and cosine with what we already know, the graph of our parent, y equals sine of x. So I don't have to do the work again. I already did it here. And what I'm going to do is look at these 5 points that I labeled and use them as my reference. So I know, I'll go ahead and draw a table over here. I know that I have these 5 points, 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. So when I draw this graph, the first thing I'm going to do is label my axes. And I'll put a 1 and a 2 and a 3 and a negative 1 and a negative 2 and a negative 3. And then out here, I know I'm going to need a 0, a pi over 2, a pi, a 3 pi over 2, and a 2 pi. All right? Now we could also go in the negative x direction. If I continue this pattern, we'll get negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so we are all labeled. We know where our 5 points are going to go. So let's put them on the graph. We have 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. So here is what our curve looks like. And we already knew that. We just spent a lot of time figuring that out. We already did the work. So we can just replicate it over here. And remember that this curve actually extends indefinitely in both directions. So I'm going to put a little arrow out to the right, and we're actually going to follow the pattern to the left. So you can tell this pattern is like 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. So if I continue in this direction, we would actually start with a negative 1, then back up to 0, then back up to 1, down to 0. So my curve as it goes to the left would look like this. And we start to see some repetition. Okay, so in pink here we have our parent function y equals sine of x. We already know its domain goes from negative infinity to positive infinity. We already know its range goes from negative 1 to positive 1. So what happens when we make some transformations to it? Our first one's going to be pretty straightforward. We have y equals sine of x plus 2. So what happens is our x's don't actually change. There is no change being made to the x. No change. The only thing that's happening is once we take the sine of that x, we have to add 2 to the result. So no longer are we looking at the same y values. Well, that's a little drastic. Let me get rid of those. No longer are we looking at those values. Instead, we're going to adjust them by adding 2 to each one. So when x is 0, y is now 0 plus 2, which is 2. When x is pi over 2, y is now 1 plus 2, which is 3. And we can go ahead and add 2 to each of these. Negative 1 plus 2 is positive 1. 0 plus 2 is 2. So these are our new y values. So let's just plot these points as we normally would. We start with 0, 2, which is going to be right here. Then we move to pi over 2, 3. Then we move to pi 2. Then we move to 3 pi over 2, 1. And then we move to 2 pi 2. So this curve in blue represents our transformed function y equals sine of x plus 2. And we can continue the pattern to the left as well. So here we had 2, 3, 2, 4. Nope, that's not what that was. 2, 3, 2, 1, 2. Now over here we should expect a 1 followed by a 2 and a 3 and a 2. So let's continue the curve out to the left. Like so and like so. So before we move on, I want you to notice one thing about these graphs. This parent function here in the middle, y equals sine of x, looks like it stays pretty close to the x-axis, right? Oh, that's a little bit sloppy, but you get the idea. The curve is only going a maximum of 1 unit above and 1 unit below that line. So this line right here, which is y equals 0, we're going to call the midline of that curve because it is a line in the middle of the sine curve. All right? Likewise, our new transformed graph has a midline in much the same way that our first midline was the line y equals 0. This one becomes the line y equals 2. And really, we did not have to do all of this table nonsense. The only thing we needed to do was recognize that this plus 2 is actually changing where the midline is. So my new midline determines where that sine curve ends up. So there are 4 different ways to transform our parent functions of both sine and cosine. We're going to be looking at transformations of cosine a little bit later. But what we just did was this plus d. D value actually represents a physical change in the graph that we call a vertical shift. All right? So this is where our sine curve is actually being shifted vertically, either up or down, depending on the value of that constant, d. All right? And there are 3 more things that we're going to look at, only one of them in detail for this video, and the other 2 will be for the following video. But we're also going to look at this value of c. And much like that d shifted us vertically, up and down, this c is actually going to shift us left to right. And we're going to call this a phase shift. All right, so if we start with a regular sine or cosine curve, the phase shift actually moves that left or right. And you might recall from earlier math classes that if you've got a minus c on the inside right next to the x, that actually shifts in the opposite direction of that sign. But we'll see that a little bit later. 2 more things that I'd like to point out. This b value actually has to do with something called the period. All right, now I'm not going to write it over here, because the period is actually a different number p, and this b is related to the period like so. But we're going to get into that in the next video. What I want you to know is that the period actually changes the shape of this wave. So if this wave has a period of 2 pi, meaning that its shape repeats every 2 pi along the course of the wave, then this wave has a shorter period. Maybe this one has a period of pi over 2, where it repeats in a much shorter time. The last one we're going to look at is this A in the front, and we call this our amplitude. Our amplitude. And we talked briefly about the midline, but the amplitude is actually this height right here in between the midline and the peaks and troughs of our wave. So that A represents how far above the midline the wave actually reaches. So in our previous example, we had an amplitude here, and that amplitude was 1 because we only went 1 unit above and 1 unit below the midline. But what we're going to look at now is an example of a phase-shifted function. So we have our y equals sine of x plus pi over 2 right here, and that shift is not going to be in the positive x direction. So let's put over here, just as a reminder, the standard form of this equation, a times sine of b times x minus c plus d. So because we're looking at an x minus c here, I'm going to rewrite this so that it says y equals sine of x minus negative pi over 2. And now we can see the true nature of the shift. We are actually going pi over 2 to the left. So what I'm going to do is, let me see if I can't. No, I made too much of a mess of that already. That's fine. I'll just draw a new table over here. So I'll put this in for reference one more time. But these are the 5 points from our parent function y equals sine of x. All right, we have 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and we have 2 pi, 0. So let's take this, move it over here. All right, so we're going to put these points on just for reference right now. This is not our final answer. Oh goodness, I forgot to label my axes. Excuse me. That's the first thing I should be doing. Let's do 0, 1, 2. So we labeled our axes. I'm not going to let you guys get away with not labeling your axes, so please don't let me get away without labeling mine. All right, this is important. So we have right now a guideline for where these 5 points ought to go if we were not making a transformation. But we are making a transformation, so we're going to use this as a reference as we shift everything pi over 2 to the left. So no longer is our first point going to be 0, 0. We're now starting at negative pi over 2, 0. And then this point here becomes 0, 1. This point here, as we move it, becomes pi over 2, 0. The one down here becomes pi negative 1. And the one over here becomes 3 pi over 2, 0. So our new transformed curve looks like this. All right, so the blue one is the one we want. The pink one is what we started with. The blue one is our goal. And we can continue the pattern out to the right and out to the left because this thing still does reach out indefinitely. And we can answer some questions about domain and range, right? Well, if we moved it left to right, the domain really did not change at all. So we are still looking at all x values as the domain, from negative infinity to infinity. Did our range change? Well, no, because we didn't move up or down at all. We only moved left to right. We still have a minimum of negative 1, and we still have a maximum of positive 1. So that range is exactly the same as we left it. I don't think I did the, let me Go back. Haha, we didn't. We didn't do the range of this one, and I should have. But let's do it now. Because we moved this curve up by 2, this actually does change the range. The domain will be the same. We're still covering all the x values, but the range is now we have a different minimum and a different maximum. So my minimum is now 1. My maximum is now 3. Cool. Glad I caught that. Okay. So we have looked at a phase shift. Let's look at a couple examples with cosine. Let's go back to our cosine. We're going to lift these 5 points as our reference. Okay. So over here. And we'll do it in pink because I like pink. Y equals cosine of x. So we have our 5 points, right? Now it's not 0, 0. We now are at 0, 1 to begin with, then pi over 2, 0, then pi negative 1, then 3 pi over 2, 0, and 2 pi, 1. Because remember, this one starts at the top, then goes to the bottom and back up to the top. And before I put that there, let me label my axes. I told you guys to not let me get away with labeling, or without labeling. So hold me accountable, but also hold yourselves accountable. This stuff is important, all right? And this is why your picture doesn't necessarily have to look pretty, is because you've already properly labeled it, and I should be able to read what you meant without you needing to be an artist. All right, so let's put this on. We have 0, 1, we have pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi, 1. So here is that curve. We start at the top, go to the bottom, then come back up to the top. And we can continue that pattern indefinitely to the right and to the left. Whoop. Okay, so our domain has not changed, negative infinity to positive infinity, and our range, thusly, negative 1 to 1. Now, we are going to shift this thing vertically. So if you will recall, where's the correct color? There it is. If you will recall our standard form of this equation, b times x minus c plus d. The only change that we're making is a plus d, but it doesn't look like a plus because it's a minus. So we are really adding negative 3 to all of the y values. Now I could go through and add 3, or subtract 3 here, 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 or I could do what I did before and think about the midline of this function. So at the beginning here we have a midline of y equals 0. And all we're going to do is move that midline down 3 units. So our new midline is 3 below where we began, and it's right here at y equals negative 3. So we're going to use that. Oh, I'm going to need this too, aren't I? We're going to use that to help us draw our new curve. And I also know that the amplitude of this curve is 1. So when I start, my point should be 1 above the midline. And when I'm over here at pi over 2, I need to be on the midline. At pi, I need to be 1 below. At 3 pi over 2, I'm on the midline again. And then at 2 pi, I am 1 above again. And we can continue this pattern as long as we need to in order to get the full picture of this new transformed cosine. And I'll try to make it looking pretty, but it really does not have to look pretty. It's just got to be labeled correctly. Okay, so there's our new curve, y equals cosine of x minus 3. Got 2 more examples. This one represents a phase shift. So once again, I'm going to rewrite this so it better matches the standard form of this equation. And this tells me that we are moving pi units in which direction? To the left. because this is secretly x minus negative pi. So we're going this way, and we will start. Let me see if I can copy paste this. Yes, copy that. Oh, come on, really? All right, whatever. We'll just go ahead and throw those in. We had a 0 and a 1, pi over 2 and a 0, a pi and a negative 1. It's not a bad idea to have this memorized, you guys, because you're going to be needing this a lot. Okay, so our original points are here, 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 and here. Okay? Oh, stop letting me get away with not labeling the axis. Come on. This first point here, we are now putting over here at negative pi. This point here that was at pi over 2 is now going to go to negative pi over 2. The point down here that was at pi is now at 0. Okay? The point that was at 3 pi over 2 is now going to be at pi over 2. And the point that was at 2 pi is now pi. So here is our transformed curve. All right? And we're still following the same basic shape, but that shape is now in a different location on your graph. So we'll draw this out a little further in both directions. So what has changed? Well, the domain didn't change. We're still covering everything, right? We're still going from negative infinity to positive infinity. And our range has also not changed. We're going from negative 1 to 1. And I've forgotten to do the range on the other one again, so let's throw that in real quick. We had negative infinity to infinity. Our new range as we moved down 3, well, we have a minimum of negative 4 and a maximum of negative 2, so that range goes from negative 4 to negative 2. Okay, last problem, and we're combining two different transformations. We have a vertical shift and we have a phase shift. So I'm going to write down a description of actually what's happening. We're moving 1 unit down, and we are moving pi over 2 units. Which direction are we going? Well, this one already has a minus in it, so I don't have to change anything about it. And that means that we are actually going to the right, because it's x minus a positive pi over 2. So these are the two things that we'll expect. And the first thing I'm going to do is draw my midline. So no longer will this midline be here at y equals 0. We're going to put the midline at y equals negative 1. But let me real quick label these. Thanks for reminding me this time, you guys. And I'm actually going to use my original points for reference of how I'm shifting. So if I was just going down, then my graph would show up right here. But that's actually not what's happening. We also have to now shift pi over 2 units to the right. So in purple this time, no, purple's too close to blue. We'll do red. We're going to move each of these points pi over 2 to the right. So from 0, we end at pi over 2. From pi over 2, we go to pi. From pi, we go to 3 pi over 2. From 3 pi over 2, we go to 2 pi. And our last point is now out here. What is this x value? Well, it's 5 pi over 2. As we count on the x-axis, we're increasing by pi over 2 each time. So my new curve actually looks like this. All right, we come down and we come back up. And we could continue this pattern to the right, and we could continue this pattern to the left. I'm not going to go all the way over there. You know that it goes all the way over there. And that means that my domain still hasn't changed. Imagine that. We are still covering all the x values from negative infinity to positive infinity. What's my new range? Well, my minimum has now moved to negative 2, and my maximum has now moved to 0. So my new range goes from negative 2 to 0. All right, go do some practice problems or something, or watch the video again if you really missed a spot.